Good morning, ladies and gentlemen. It's Mr. Pearson coming back to you again with another video. It is Wednesday, October 21st, and this video is going to support Activity 3.2. So Unit 1, Investigation 3, Activity 2. Looking at our survey from Monday, in combination of us just going back to school, I think we are going to move to mostly screencasts. If I see the need for us having a question session, or if you're one of those people who has got a ton of questions, we need to set up a live conference. We can do that. But I think these videos are easier. One, because Teams was proving to be an issue for some, just how complex it is. And two, I think it's nice for you guys to be able to go back and watch these videos. Again, especially with you guys being in on Mondays. I'm in on Mondays. I'm also in on Wednesdays, which, by the way, it was awesome to see some of you guys. If you see me in the hallways, say hello. I noticed I didn't have anyone in my shop area, which kind of stinks, but again, just want to be friendly, see how you're doing, and say hello. So that's that. I don't want to make this one super long, so let's get down to it. First, want to review Activity 3.1. All right, there was a lot of great vocab that you guys used in the warm-up, because we are now getting away from talking about just charges, and 3.1 brought up the question about particles versus something called the continuous model, right? So we have two different models of matter. And, presented us with this thought experiment. It says, okay, we have a piece of paper, let's cut it in half. Okay, and I can sort of go back here. Let's cut it in half, right? So I would have two pieces of paper. Then I can cut that in half and I would have 4. Then I'd cut that in half and I have 8. Then I'd cut that half, 16, 32, 64, $1.28, so on and so forth. So the question really that I was posing to you is that if we get down into sizes like this, or even way smaller, right? It'd be tough to cut this in half. But if we had these crazy, scientifically advanced, technologically advanced tools, how far could we go? So a couple good questions popped up. Remember to use this to our advantage. This is going to drive our conversation and I think help us understand a little bit more. Some of us have been doing a great job. Some of us not so much. Okay. So the big question is if we continue to make these pieces of paper smaller, are they still going to be paper? We do have one of our same essential questions. Our big one being, why do clothes stick together? And you'll see I mainly just sort of did a quick summary of investigations 1 and 2, right? We know that opposite charges attract and like charges repel. When they're not touching, they interact through electric fields. When they are closer or the charges are larger, the forces are stronger. Quick and easy summary. Probably oversimplifying it, but that's okay. What are our particles made of? Again, we're really just introduced to the idea of a particle, so I just put that with a question mark, right? Some of us might know what it is, some of us might not. There is some mention of that in your middle school science classes, but the vocab it varies for sure. Our last one, can the same piece of paper be cut into pieces indefinitely? I put maybe. It seemed like most of you guys thought probably not. And that gets into this question right here. At what point are we going to have to stop? Is there a point where that paper is no longer paper? And if so, what is it? So some good thoughts there. Looking at activity 2, 3.2, okay, there is an experiment, that you will see referenced a few times here. Unfortunately, this is one that I would really like for you guys to have done. Um, Tomorrow, because I'm in tomorrow and I have my lab activity and materials at school, what I'm going to do is I'm going to film the experiment, and I'm also going to film another demonstration, which is probably going to be a lot easier for you guys to see. Um, that will hopefully help you guys visualize this a little bit more. This first part here is more of a hypothesis. Okay, so we're talking about particles versus the continuous model. And I'm very curious to see really what you guys think before I give you that visual through the video. And it'll pop up through the simulation that you're able to work on today. But again, just curious to see you guys make a guess and a hypothesis before I give you too much. What you can use, if you do get to the questions that involve the experiment, I included my class data from last spring. So this is an experiment that we did last spring, I mean, past couple semesters. And if you click into that, you'll see that there's sort of 3 trials. The idea of the experiment is that you take 5 milliliters of 2 liquids and you mix them together. In one iteration of the experiment, we take water and we mix it with water. In another one, we take ethanol and we mix it with ethanol, which is like ethanol is like a almost like nail polish remover. It smells like, but it's a clear liquid. You'll see that in the video. And then we take water and we mix it with ethanol. All right. If we look at when we mix the water and the water, we have a very little loss. So what we're doing here is we mix them together and then we calculated it. So I have my calculated volume, and then I have my observed volume. And this yellow column here is how big of a difference it was, right? Because sometimes we might leave a little drip of water behind or a little drip of ethanol behind. And we can see when we mixed water with water and we mixed ethanol with ethanol, we had a very little difference, a very small difference between our calculated and our measured volumes. However, when I look at the water plus the ethanol, I have a much larger difference. Okay, and you can see I took my group numbers, and then down here at the bottom, this is my own trial. This is another science teacher in the building. He tried it himself. That was the average difference. So we're talking almost half of a milliliter here. Talking about 10%. Imagine if just 10% of your grade just disappeared. So when we mixed the water and the ethanol, it showed us a much larger difference between our calculated and our observed volume. So do keep that in mind as you work through here, okay? This submission here, you should be submitting a screenshot of these models right here, okay? Some people have been confused on what to submit screenshots of. Be sure to take a screenshot of the actual interactions page. All right, there's a simulation here. You can open this up. I think when I had put this together originally, the simulation might not have been working, but it looks like it should be good to go now. So those are really 2 of the same things. You know what I'm... So work through that. You can work through the interactions page at the same time. Like I said, tomorrow I'm going to film in the morning a video for you guys to check out about that demonstration and just give you a little bit of a better understanding. Okay, if you want to wait to do the modeling portion until you see that, okay by me. Again, give it a shot though. I'm very curious to see what you guys are thinking of. Before we get too much of that exposure. And likewise, I'll publish the check for understanding once that's all taken care of tomorrow. So let me know if you have any questions. As always, I'll be on Schoology. Just because we're not going live doesn't mean I'm going anywhere. I just think it's an easier way for us to have less time together. I think this is going to be an easier way for us to streamline and just become more efficient. So I will see you guys later.